In this module, we move from individual security agents to coordinated security teams. You'll see how agents specialize, route work, collaborate across SOC, cloud, IAM, and endpoint workflows, and escalate when human judgment or conflict control is needed. So far, we've covered what security agents are, where they operate, and how they connect into enterprise platforms. The next step is coordination. Who acts, who decides when to escalate, and how agents avoid working against each other. Security operations span too many domains for one agent to act safely on its own. Endpoint, identity, cloud, network, email, and business context all require different evidence, tools, and permissions. Coordination lets specialized agents investigate, contain, escalate, and report through shared control, with humans involved where judgment matters. Without orchestration, teams risk duplicated work, conflicting actions, missed handoffs, and unsafe automation. The goal is unified defense, not isolated automation. In a SOC, the generalist agent usually acts as the case coordinator. It owns intake, tracks context, decides where work should go, and synthesizes findings into a coherent answer. Specialist agents go deeper. A phishing agent can inspect headers and URLs, while an IAM agent reasons over identity behavior. The trade-off is control versus depth. Give specialists narrow tools and permissions, and let the coordinator maintain continuity and escalation. Multi-agent systems work best when every agent has a clearly bounded job. Before deployment, define the mission, inputs, tools, permissions, outputs, and escalation path. In higher-risk workflows, separate investigation from recommendation and execution, so no single agent silently drives the outcome. Also, assign one lead owner for each case. A RACI-style model makes this explicit: who acts, who approves, who is consulted, and who must be informed or audit the result. Coordination is more than adding agents. A hub-and-spoke model works when one coordinator can assign tasks and combine findings. Tiered escalation fits high-volume triage, where routine cases stay automated and difficult cases move upward. Swarm investigation supports complex incidents, with agents examining logs, identities, endpoints, and network evidence in parallel. For risky actions, human-supervised orchestration keeps authority with analysts while agents provide recommendations and context. Routing is the handoff logic that keeps work moving to the right place. Start with the signal: alert type, asset, threat category, and business criticality. Then use rules and model classification to choose the likely path. Confidence matters. High confidence work can go directly to a specialist agent or automated tool. Low confidence, high impact, or conflicting evidence should trigger human review. Store the rationale so analysts can trust and audit the decision. Escalation is how an agentic security system avoids overconfidence. Low-risk signals can be handled by automation or first-level triage, but uncertainty, severity, critical assets, regulatory exposure, or destructive actions should move upward. Each tier has clearer authority. Specialists validate complex findings, incident commanders coordinate response, and executives are notified when business impact is material. The key design choice is explicit ownership and SLAs, so decisions move quickly without allowing risky actions to bypass human approval. A coordinated SOC workflow splits triage into specialized handoffs. Intake agents normalize alerts from tools like SEM, EDR, email, cloud, and identity systems. Enrichment agents add context: asset criticality, user role, location, threat intelligence, and incident history. Analysis agents turn that context into likelihood, impact, severity, and confidence. Finally, coordinator agents package the findings into a clear case narrative, recommended actions, and ownership for the analyst or ticket queue. When several agents touch the same asset at once, coordination becomes as important as detection. One agent might isolate an endpoint while another re-enables access. Two workflows might create duplicate tickets from stale data. That is a race condition. Decisions happen before shared state catches up. The fix is not just faster automation. It is controlled automation, with locks, clear ownership, sequencing rules, and state synchronization before each action. Conflict prevention works best when it is built into the system from the start. Give every agent a shared source of truth for ownership, evidence, decisions, and current work. Require locks, reservations, or approvals before sensitive actions. Make operations idempotent, so retries produce the same safe result instead of duplicates. And define escalation rules in advance. When agents disagree, the system should know whether to vote, defer, roll back, or ask a human. In multi-agent security, logging is not just a compliance record. It is the evidence chain. Every action should tie back to an agent identity: task, case, input context, tool call, policy check, confidence score, and outcome. That includes actions that succeeded, failed, or were blocked by guardrails. The goal is traceability across handoffs and human approvals, plus operational visibility into latency, errors, escalations, and automation accuracy. Explainability turns an agent's decision from a black box into an operational argument. In a phishing or malware escalation, the agent should tie each claim to telemetry, the alert, behavior anomaly, and suspected lateral movement. It should separate observed facts from inferences, state confidence in plain language, and name uncertainty. Then a recommendation, such as isolating a system or blocking a command server, becomes reviewable, challengeable, and appropriate for the analyst's role. Consider an identity alert for impossible travel. The coordinator does not act alone. It asks IAM to validate access signals, cloud to review API activity and privilege changes, and endpoint to check for malware or token theft. Then it merges the evidence, scores impact, opens the case, and routes high-risk containment to a human approver. The takeaway is clear. Effective agentic defense is an operating model, not a pile of agents. Define roles, permissions, handoffs, routing, escalation, conflict controls, and observability. When agents collaborate with shared state, logs, explainability, and human oversight, they become safer and more useful. Next, we examine design patterns and anti-patterns.